NASA has proposed a sci-fi plan that could potentially shut down the supervolcanoes if there are signs of an imminent eruption. However, such a geological scheme may not be necessary. In new research conducted by NASA's Goddard Institute for Space Studies and Columbia University, scientists found that the most powerful eruptions that eject large amounts of material into the atmosphere probably would not plunge Earth into a deep, cold volcanic winter.
It's true, the huge amounts of gas and ash thrown into the sky by the supereruption, which erupted more than 240 cubic miles, 1,000 cubic kilometers, of magma, would have blocked sunlight and had a cooling effect. According to recent research, this is unlikely to have a negative impact on life globally.
The relatively small temperature changes that we consider most consistent with existing evidence may explain why none of the supereruptions produced strong evidence of a global-scale catastrophe for humans or ecosystems. Zachary McGraw, lead author of the study and a researcher at NASA GISS and Columbia University, said in a statement, "The research was recently published in the peer-reviewed Journal of Climate."
For reference, the eruption of Mount St. The famous St. Helens event in the US in 1980 that was so powerful that it completely blotted out the sun in Spokane, Oregon, located 250 miles away, released 0.67 cubic miles of volcanic rock. Although impressive, this number is very small compared to supereruptions.
Of course, it is impossible for Earth scientists to analyze the recent supereruptions, rarely happening. The last such event occurred more than 22,000 years ago at Taupo in present-day New Zealand. Yellowstone, in the US, is also widely known for its supereruption capabilities. Several Yellowstone eruptions over the past few million years created layers of volcanic lava rock more than 1,300 feet, 400 meters, thick.
Due to the lack of direct observations of the explosion, scientists use computers to simulate how such a massive event would impact our planet. The main ingredient in prolonged volcanic cooling is not ash, which is actually small fragments of volcanic rock. It is sulfur dioxide gas from the volcano that condenses into liquid sulfate particles.
Once high in the sky in the Earth's stratosphere, about 6 to 30 miles above the Earth's surface, sulfur dioxide reacts with atmospheric molecules to produce droplets that can persist for a year or more. And when sunlight hits these droplets, the energy is reflected back into space, greatly reducing our planet's supply of sunlight.
NASA research simulated how these gases, ejected into the stratosphere during supereruptions, would impact temperatures at Earth's surface. Drastic cooling can destroy plants, plant life, and many ecosystems. But simulations show that although cooling will occur, it will not trigger temperature changes greater than the largest eruptions in modern history.
Generally, you always think of volcanoes cooling, but this research says there are limits. Valentino Aquila, an atmospheric scientist at American University who researches the impact of volcanism, told Mashable, Aquila had no role in the research. Cooling has its limits because supereruptions will throw large amounts of particles into the atmosphere.
But when they got there, they gathered together. Most importantly, larger particles are less efficient at reflecting sunlight than smaller particles, because there is less surface area to reflect sunlight, Aquila explains. What's more, larger droplets will fall faster from the sky.
Sulfur particles also trap heat radiating from the Earth, similar to the greenhouse gases currently causing climate change. So, although some of the sun's radiation is blocked, Radiation originating from our planet is also absorbed, causing a temporary warming effect. You get these two counteracting effects. McGraw Old Mashable.
Of course, the impact of the supereruption will still have a regional negative impact. A supereruption would cause major problems near the eruption site. Around Yellowstone, parts of Montana, Wyoming, and Idaho would be hit by streams of very hot rock, ash and gas, called pyroclastic flows, the U.S. Geological Survey said. Mass evacuation is necessary to avoid large numbers of casualties. Approaching the eruption, day will turn into night. Ashfall will spread across much of the U.S.
But humanity will not be threatened. We are confident of this because there have been two large explosions while humans were still on Earth, and both were actually larger than the most recent powerful eruption at Yellowstone. Volcanologists do not see an imminent supereruption, but, fortunately, the volcanoes will show signs of it long before the event. We'll get plenty of warning.